Excellent. I taught you a new operation yesterday. It was called composition. Composition of functions. Today I teach you inverse of functions. Okay? In order to talk about inverses, we first must define what it means to be a one-to-one function. A one-to-one function is a function, or a function's one-to-one if every element of the domain corresponds to exactly one element of the range. Does that sound familiar? Where did we hear that before? That's the definition of a function, but it continues on. And every element of the range corresponds to exactly one element of the domain. Every element in the domain corresponds to exactly one element in the range, and every element in the range corresponds to exactly one element in the domain. Okay? So here's your example. In order for a function to be one-to-one, it must pass the horizontal line test. So please listen carefully as I ask this question. I have a graph of a parabola. Is it a function? Yes. Why is it a function? That's the vertical line test. Is it a one-to-one function? No. You can pick an output. We said 3 for like 3 goals. Okay, there are 2 different people, person X of 2 and person X of 1, that scored those 3 goals. Therefore, it's not one-to-one. We don't know who scored the 3 goals. So it's a function, but it's not one-to-one. Is that a function? Is it one-to-one? Yeah. Passes both the horizontal and the vertical line test. Very good. So now that you understand what one-to-one is, if a function is one-to-one, we can find its inverse. So function inverse would be f inverse. That's what it looks like. Here's what it means. X's become y's and y's become x's. It means the domain becomes the range and the range becomes the domain. So for example, if I have 1, 3, 4, 6, and 7, 1. That's a function. Every element of the domain corresponds to exactly one element of the range. If I ask you, what is f of 1? If I plug in 1, what do I get for an output? I get 3. Any question there? If I ask you f of 7, what would you tell me? You tell me 1. If I ask you f of 4, what would you tell me? 6. Suppose I ask you f of 6. Is there an x value of 6 that can tell you the output? There's not. We don't know what that is. The inverse asks this. I'm going to do f inverse of 6. F inverse of 6 means, given a y value, what's the corresponding x value? It is 4. Or if a person scored 2 goals, who was the person who scored the 2 goals? Tell me who the person was that corresponds to it. If I ask you f inverse of 3, you would tell me 1. And if I ask you f inverse of 1, you would tell me 7. What if I ask you f inverse of 4? We don't know because there's no y value of 4. Graphically, inverses are reflected over the line y equals x. We're going to look at that in a second. So that's a basic introduction into your inverses. Let's do some problems to practice our operations on inverses. F inverse of 8. That means if you have a y value of 8, what is the x value that corresponds? What do you think? Yes, -3. So F inverse of 3 is 2. And F inverse of 5 is, and F inverse of 9 is 1. Easy peasy, huh? Conceptually, it can be challenging. Some of the operations aren't very bad at all. This is a little bit different. Given the function is 3x minus 8, find f inverse of 6. So again, I have a y value of 6. I'm looking for the x value. Any idea how I can do that? Do I put the 6 in for the x, or do I put the 6 in for the f of x? So 6 equals 3x minus 8. Or 14 is equal to 3x. So f inverse of 6 is 14 thirds. That's the result. Kid just chucked. Here we go. Instead of giving you a value, we're going to give you a function. We want you to find the inverse of the entire function. Sounds challenging, huh? Super easy. This is y is equal to 2x minus 5. The way we find the inverse is we swap the x and y values. X is 2y minus 5. When you do that, you then solve for y. We add the 5. X plus 5 is equal to 2y. Divide by 2, and y is x plus 5 over 2. Take out your calculator. That's f. That's f inverse. See that? What I'm going to do is I'm going to type it in my calculator. I'm going to type in 2x minus 5. And I'm going to type in x plus 5 divided by 2. I also type in the line y is equal to x. What I should see is both lines graphed and one being reflected over the line y equals x. Let's see if it follows what we think. There's the first one, there's the second one, and the line y equals x. Can you see how if you flip one over the line y equals x, you get the other one? That's a good indication I did the problem correctly. What's different about letter B? Got a fraction, and I end up with 2 y values instead of 1. How are we going to solve that? How? What are you going to do? Give me the first step. Cross multiply. 2 minus y is equal to 3xy minus 4x. Am I trying to solve for x or am I trying to solve for y? Trying to solve for y. So what are you going to do now to solve for y? Okay, Carson's got it. Before I factor out not the x, I factor out the y. Before I do that, I have to get the y's on the same side. This was a problem from your first test. This was a problem from your final exam. People were still getting this wrong on the final exam. I don't want people to get this wrong on this test, folks. It'll be the third time you've seen it. I don't give you stuff just because I want to give it to you. I give you the stuff that you're going to have to do someday. By the way, the calculus test, they had to do this about 3 times on their last test. It doesn't go away. We got to handle this. We add over the 4x and get 2 plus 4x is equal to 3xy plus y. Carson said factor out the y. 2 plus 4x is equal to y times 3x plus 1. So 2 plus 4x over 3x plus 1 is equal to y. Pretty sweet, huh? Flip it over. Sometimes you know exactly what the graph looks like. 2 minus 3x cubed. It's a cubic. It's upside down. It's shifted up 2 units. Everybody agrees that that goes through the point 0, 2. So we'll see if you've been paying attention. If that function goes through 0, 2, what is its inverse going to go through? 2, 0, right? So I'd like to see an inverse that goes through 2, 0. If it doesn't, then I did something incorrectly. They switch x and y values. So I'm going to go x is equal to 2 minus 3y cubed. Subtract the 2, x minus 2 is equal to negative 3y cubed. Divide by negative 3, x minus 2 over negative 3 is equal to y cubed. And then cube root both sides. Cubed root of x minus 2 over negative 3 is equal to y. Sometimes I regret writing this problem because technically the denominator is not rationalized. I don't want to go through that work right now, so we'll just try not to encounter that. Okay. So I get that. What I'm going to do is I'm going to graph it on my calculator and make sure it does what I thought it was going to do. I've got this 2 minus 3x raised to the third. And then down here, I'm going to go math, cubed root number 4, and parentheses x minus 2 divided by negative 3. And I'm going to graph those. First one, yep, just like we drew up here. Go to, what did I hit? You got an extra parenthesis. There it goes. It goes through 2, 0 like you thought. And does it look like it's reflected over the line y equals x? It's pretty sweet. This is where things fell apart last hour. It's really not that bad. Do you know what the graph looks like? What does that graph look like? The square root thingy. Very good. You guys got it. Left 1, up 4. And I saw you guys make that shape with your kind of your pencil in the air. You're like, yeah, it goes off the side like that. Good. So if it starts at negative 1, 4, then we would expect that its inverse would start at 4, negative 1. Well, let's find the inverse and see that play out. X equals 4 plus the root of y plus 1. What to do? X minus 4 equals the root of y plus 1. X minus 4 quantity squared is equal to y plus 1. X minus 4 squared minus 1 is equal to y. I left it as a parabola in vertex form because it's easy for me to identify the vertex. What's the vertex of this parabola? Four, negative 1. That's what we thought, right? But watch what happens when we graph it. We get this, and we get that. Now, I don't know about you guys, but I wasn't anticipating to get all of that when I reflected the radical over the green line. If I reflect the radical over the green line, I don't get all of that, do I? You see, when you squared both sides, you ended up with more than what you wanted. The green or the black one, the radical one, does that pass the horizontal line test? It does. Does the parabola pass the horizontal line test? No. You see, when you square both sides, you added more than you wanted. So what we need to do is we need to get rid of half of the graph. Do you think we keep the left side or the right side? Look at it. We keep the right side. So I want to get rid of the left side. And here's how I do it. It's no big deal. I just say, I want that graph, but only for a specific domain. What is the first x value that I want for the graph? 4. And it goes off to infinity. So if you find an inverse, but you arrive at a graph that doesn't look like the inverse of the other one, then you have to make sure that you isolate the domain. Not too bad, huh? I want to show you one small connection piece I think is important here. Hopefully it doesn't upset anybody. Would you agree if you look at that original one that the domain is, in fact, -1 to infinity? And the range is 4 to infinity? Well, what did we say about inverses? The domain becomes the range and the range becomes the... Well, look, the range, it matches, doesn't it? So that confirms that you did it correctly. The last hour, the frustration was, well, why don't you just do that right away? Well, you still have to find the actual function, and you can just look at the function and see it, and then there was disaster broke out. It was like World War II. Why are you making us do all this extra work? Why not just find the range and throw it over there? Because that's not the answer, folks, is this. It's not just the blue, it's the function as well. We just want half of the function. This is what says we get the half. Did you follow that? Good job. The rest of the lesson is easy. You are ahead of the rest of the group. Yep, today's a tougher one. So we're gonna get into the 30-minute time frame. So you can handle it. Last thing, test to see if things are inverses. In order to see if functions are inverses of each other, we compose them. You take f of f inverse, and it should produce x. You use what we did yesterday. That's why we taught you yesterday. Function composition. You use composition to determine if they are inverses. For example, 1/3 and 3 are inverses under multiplication because when you multiply them, you get 1. And 4 and -4 are inverses under addition because when you add them, you get 0. Functions are inverses if when you compose them, you get x. But it is not commutative, so you must compose them both ways to show that you get x in both situations. So this is actually kind of fun. It says, use the property of inverses to determine if f and g are inverses of each other. And what we do is we compose. F composed of g. So what do I do? What does that mean? I take that guy, and where do I drop it? I get 3 times the quantity, and I need you to make sure you're careful with your work. Please put parentheses wherever you have an x. It'll help me follow your work. -5. Does that simplify? What happens? Okay, but if you just write x, I'm going to take a point off. I need to see what cancels. What cancels first? The 5s or the 3s? The 3s. So you're left with x plus 5 minus 5, which is x. Not enough to compose one direction. We have to compose both directions. If I do that, I get 3x minus 5 plus 5 over 3. What cancels? What cancels first? No, the 5s. So we get 3x over 3 is equal to x. Not too bad, huh? What's different about the next one? Fractions. You're going to take this guy and put it right there. Again, if you use parentheses, it helps you organize your work. 1 over x minus 2 in parentheses. Then what do I have after that? Is it on the outside or is it underneath the denominator? Yeah, it's underneath that division sign, right? So what cancels first? the 2's. I get 1 over 1 over x. What is 1 over 1 over x? It's x. If we compose them the other way, we get 1 over x plus 2 minus 2. What simplifies here first? Do you do the reciprocal or do you do the minus 2 first? Reciprocal, and we get x plus 2 minus 2. Is a parabola 1-to-1? It's not. But if you isolate the domain, notice this problem. It's a parabola, 4x squared, but just for x greater than 0. So they got rid of that. Is it now 1-to-1? Yeah. You don't need to do anything different with the problem. That's what that means. See if you can compose these and show that they're inverses. Go. Oh my gosh. Oh, thank you for your honesty. I appreciate that. All right, let's check it. F composed of G. So what you should have is take this guy and dump it in here. So 4 times the root of x over 2 quantity squared. I get 4 times x over 4, which is x. That's what you should be showing. And G composed of F. You're going to take F and dump it in there. The square root of 4x squared over 2, which is 2x over 2, which is x. You good to go? You know what people do on the test? It says, use the property of inverses to determine if they're inverses. Here's what people do, okay? Because they don't pay attention to the directive. You have to use composition. What they do is they switch x and y. So they put in y for x, and they solve, and they come up with that. Great, I get it. You're able to find the inverse. It doesn't say find the inverse. It says show that they're inverses. You must use composition. If you don't use composition, it's wrong. Okay? Simple as that. All right, last example. What do you notice about these two? They are the same. Do you think it's possible for two functions to be the same and to be inverses of each other? It is. Totally possible. F composed of G would be 1 over x cubed cubed. One over x to the 9th, which is I didn't get x, did I? They're not inverses. Don't even need to do the other one. That's that. Good work. Way to go.